Hey all listeners, this is Prajesh Chaudhary Quantum Group. In this video, I am going to discuss a very good question of magnetic effect of current from JEE Main 2025. Usually questions of JEE Main are physics. JEE Main physics are easy to moderate level, but this one is really a challenging one. So let me read the question and I'll proceed to solve. Question states, consider long thin conducting wire carrying a uniform current I. A particle having mass m and charge q is released at a distance a from the wire with a speed v naught along the direction of current in the wire. The particle gets attracted to the wire due to magnetic force. The particle turns around when it is at a distance x from the wire. Find value of x. Alright. So here is a diagram. This long straight wire carrying a current I, and I have put it along y-axis, and a charged particle having charge q mass m at a distance a from the wire is projected parallel to the current, and I have put everything in the xy plane. So it has a magnetic field to the right of this here. Everywhere the magnetic field will be in the cross direction, and this is a non-uniform magnetic field. So at a distance x from the wire, value would be mu naught I divided by 2 pi x. So immediately as it is projected, field is into the plane, velocity is above, so there would be a magnetic force qv cross b along this direction. So this will make it attract towards the current. So charged particle will start deflecting towards the wire. Had the field been uniform, the charged particle would move in a circle, but the field is not uniform. Nevertheless, it will get attracted towards the wire. I am not interested right now on the exact path, but it will move towards the wire, and following this path like this, this is the point where it will turn back. The velocity was that, and the velocity here is turn back. The direction of velocity has changed. So we have to find this distance, and this distance I have written x2, and that is also one important point where the velocity has become parallel to x-axis or perpendicular to y-axis. So that is that point, and at this point distance of the charged particle with the wire I have taken as x1. x1 is an intermediate thing, but it would be used in solving. Alright. So basically we have to find x2. And one more thing, magnetic forces do no work. Magnetic forces do no work because it is always perpendicular to velocity. So it cannot change the speed. So at all points it will have a same speed v naught. So let me name these points. Suppose this point is A, this point is B, and this point is C. Starting the velocities in the xy plane at the initial moment, the force is towards negative x direction. So everything is in xy plane. So particle will remain in the xy plane. Alright. So now suppose at a general moment, suppose particle reaches here and its coordinate is say x comma y, and magnetic field here, magnetic field at this position B would be mu naught I divided by 2 pi x, and if I want to write in a vector form, so this is into the plane, so that I can write b into minus k cap. So at this moment, suppose velocity is like this, and velocity is always same in magnitude, so value would be v naught, and this will have components vx and vy. So I want to apply Newton's second law, F naught is equal to ma. So ma, and it will have also acceleration in this plane. So ma is mass times acceleration. Acceleration I can write ax I cap plus ay j cap, and that would be q v cross p. So force would be in this direction. The force would be perpendicular to velocity, and this force is making it deflect. All right. So the force I would write Q. Velocity vector I can write Vx I cap plus Vy j cap, and magnetic field is minus B k cap. Just simplify these things. So simplifying this thing would be QB, take here, Vx I cap cross minus k cap, B I have taken here. So that would make minus I cap cross k cap is j cap, and there is a minus. So Vx j cap. And this part Vy into B, j cross k is I, and there is a minus, so that is a minus Vy I cap. So see, basically I have to work on the x coordinate. So I will take the x component of this equation. So let me take max is equal to, the x component would be minus qb into Vy. How I can get Vy in terms of x? See, the speed is a constant. So Vx square plus Vy square is always V naught square. Oh, Vx square plus Vy square is always V naught square, and that's how I will convert Vy into in x. And this Ax can be written as a Vx dVx by dx, and here let it be like that, QB Vy. So just rearrange the things. Vx dVx divided by Vy is equal to minus QB by m, and dx I'll take on this side, dx. At this moment I want to put the value of b. So if I put the value of b here only, we'll get b is mu naught I divided by 2 pi x. At this position is at a distance x from the valve, and dx will come here, so dx will come here. So see this part, let me separate, and this part LHS has a something, this is velocity by velocity, and this is also velocity, so it has a dimension of velocity, and dx by dx is dimensionless. So this part, whatever inside this loop, should be something of velocity dimension, and that is a constant thing. So I don't want to carry this on these equations, big equations. So I just want to replace with a simple value, say u, and later I will replace that. So that is minus dx by x. So now let me take this on to next page. So what we got? We got Vx dVx divided by Vy is equal to minus u dx by x. And see that Vx square plus Vy square is equal to V naught square. So Vy can be written in terms of Vx. Alright. That would be square root of V naught square minus Vx square. But when you take a square root, there would be either plus or minus. When we'll go from A to B, the Vy is positive, and when we go from B to C, Vy is negative. So from A to B, Vy is a square root of V naught square minus Vx square, and from B to C, Vy is equal to minus of a square root of V naught square minus Vx square. So here Vx dVx, first of all let me do it from for A to B. So for A to B I am writing this Vx dVx divided by that would be square root of V naught square minus Vx square, and here minus u dx by x, and then we'll integrate and see the limits. At A, x is equal to small a. At B, x is equal to x1. At A, Vx is 0. And at B, Vx is minus V0. So put the limit here. So this goes from 0 to A, and this goes from 0 to minus V0. For this integration, this is a simple integration. What we will do, we can take this thing, square root of V0 square minus Vx square. We can take this sum W. Right? So just take a differential on both sides. So taking differential on both sides, differentiation of root is 1 by 2 root. So 1 by 2 root V0 square minus Vx square, and go inside the derivative square root. So that would be minus 2Vx dVx, and here that is a dW. So this and this will get cancelled. So that is basically Vx dVx by this, and that is a minus dW. Integration of minus dW is minus W, and this put here the value of W. So this integration would be minus of V0 square minus Vx square, and the limit will go from 0 to minus V0. And that would be simple integration. Here the limit I have put a bit wrong. Let me correct that. The x goes from A to x1. So let me correct the limit. The limit of x is from A to x1. This integral would become, what it will become? U ln x1 by A. Let's cancel this minus sign. So putting the limit, if you will put the first upper limit, so that will be 0, the lower limit will give V0. So that would be minus V0 is equal to U ln x1 by A. So V0 is equal to U ln, just flip this thing, A by x1. And similarly, if we go from say B to A, B to C, everything would be the same. Here, this integral would be Vx dVx, and as we discussed that from B to A, B to C, the Vy is negative, so Vy would be minus of square root of V0 square minus x square. So this Vy would be negative of square root of V0 square minus Vx square, and this part would be the same, minus U dx by x, and we can put the limits. Limit again you can see here, x is x1, Vx is minus V0, here x is x2, Vx is 0. So the limit x1 to x2, x2 is the required thing, and this is minus V0, and this is 0. This integration was minus W, so this integration would be W, and W mean this. So this integration would be square root of V0 square minus Vx square. Put the limit minus V0 to 0, and here that is a minus U ln x2 by x1. All right. Just put the limits. Upper limit will get V0, and lower limit we will get 0, and this here we can flip. So U ln x1 by x2. So we want to eliminate x1. We have to find the x2. So add these two equations. If you add these two equations, so you will get 2V0. 2V0 is equal to, you will take common, ln A plus ln B is ln AB. So u into ln a by x1 into x1 by x2. So that would be u ln a by x1. Now let me take everything on to the next page. So we got 2v naught is equal to u ln a by x1. ln a by x1. So ln a by x1 is equal to 2v naught by u. So a by x1 is e power 2v naught by u. So x1 is equal to a into e की power minus 2v naught by u. And now remember what we had replaced u for. For this whole thing I had put u. So in place of u I will put q mu naught I divided by 2 pi m. So here let's put the value of u. So minus a into e की power minus 2 2v naught, and u was q mu naught I divided by 2 pi m. So finally on simplification we will get x1 is equal to e, before e there is a into e की power minus 4 pi m v naught, and divide by q mu naught I, and that is our answer for this challenging question. Thank you.